In this video, we're going to do some extra advanced counting examples. Here we're going to illustrate some other special techniques that we use sometimes for some of the more challenging problems. But not all of these problems are going to need extra techniques. So, suppose I have 6 different chocolates in my office and 4 students that come to visit me as a group. So first of all, I want to know in how many ways can I give 1 chocolate to each student. Okay, so the chocolates are different. The students are also different because they're people. So I want to give 1 chocolate to each student. So think about how to break down this problem. I'm going to go to student 1 and then give them a chocolate. And then I'm going to go to student 2 and give them a chocolate, okay, etc. So I could break this problem down using the multiplication principle into 4 steps. Okay, so student 1, 2, 3, and 4. So for student 1, I have 6 options for chocolates to give them. For student 2, I obviously can't give them the chocolate that the student 1 already got. So I have to decrease every time. So I'm going to get 6 times 5 times 4 times 3, which is also 6 permute 4, which is going to be 360 different ways. Okay, now slightly different. What if I want to give out all 6 chocolates and I don't care about fairness? So one student could get all the chocolates. I could distribute them semi-fairly. I don't really care who gets what. So I could give my favorite student all 6 chocolates. Here, because I want to give out all 6 chocolates, and the people are the ones who could get more than 1, I want to break this down into 6 steps. Okay, so 1 step for each chocolate. So then when I go to give away chocolate 1, I have 4 options because there's 4 students I could give it to. Similarly, for chocolate 2, because I can give to the same student, I'm going to have 4 options for each of the 6 chocolates. So I'm going to get 4 to the power 6 or 4,096 different ways to give out all the chocolates. So sometimes it can be hard to tell the difference. Which category should be my spaces, and how do I know where the options are? So once you've picked which are your spaces, then the options should be easier to come by, but it can be hard to tell. Okay, so the idea here is that each student was getting something, and here I'm giving out the 6 chocolates, but I don't care who gets what. But in order to complete the task, I have to give out all the chocolates. In the first way, in order to complete the task, I have to give a chocolate to each student. Okay, so that's sort of how I'm breaking it down. So I want to think, what do I actually need to do in order to complete the task? Okay, let's try another one. So again, I want to give out all my chocolates, but this time I want to be fair as possible, maybe. So I want to make sure that every student gets at least 1 chocolate. Okay, now this one is challenging. So remember, when we see at least or at most, we're kind of thinking maybe cases could be useful. It's always easier to count when you know what's happening. So let's say I'm going to try and think about what could happen in a picture. So let's say that I have my 6 chocolates I'm going to call 1 to 6, and my 4 students I'm calling A, B, C, D, E. So A, B, C, sorry, D. So now I want each student to get 1. Okay, so what happens if I just randomly give everyone 1? I'm going to have 2 chocolates left that I need to give out. So the ways that I could give this out is I could give them to the same person so that somebody gets 3, or I could give them out to different people so that 2 people get 2. So maybe here I'm going to give them like this. So I have 2 special people instead of just 1 special person. Now, so there's 2 drastically different ways in which this task could be done. Obviously, it's one way or the other way. I can't do both because they have the chocolates going to the students are getting different numbers of chocolates. So these are going to be my cases. Okay, so this one I'm going to call case 1, and we're going to count it separately from case 2. Okay, and then I'm going to have to add these 2 results. Okay, so I want to decide how to count case 1. So I actually don't want to do it the way that I sort of drew the problem, so in that order. The way that I want to start is by, like, think about if you were the teacher and you were trying to give out the chocolates, okay? I know that I have 4 students, and one of these students is special, okay? Because in this case, one of them is getting 3 chocolates. So my first thing I could do is decide who this special student is. Okay, so maybe we pick the special student, okay, because they're getting 3. And then maybe we want to give them their chocolates. Okay, so give 3 chocolates to that student so that they're done. Okay, so let's count that. Let's start counting this. So if we want to pick a special student, there's 4 students to pick from, and I want 1. So this is going to be 4, choose 1, or 4 ways to do that. Now I want to give 3 chocolates to that student. There's 6 chocolates to give, and I want to give them 3. The order doesn't matter because they're all going to the same student. So I'm going to do 6, choose 3 to give them out. Okay, now none of these students are special from each other because they're all getting 1. So I don't want to pick them. So I could just have my next 3 steps. Okay, so this could be give to A, give to B, and give to C. So I don't want to pick A, B, and C because they're not special. Okay, now I'm using A, B, and C. I'm supposing that we know that we pick special student D. So these people are all the same in some ways, and what that I mean that they're all getting 1 chocolate. So all I want to do is give out the chocolates. Okay, so when I do A, I have 3 chocolates left, and I want to give them 1, so that's 3, choose 1. Now B, I only have 2 chocolates left, and C is going to get the last one that's left. Now notice these 3 things could be combined into a 3 factorial. So that's case 1. So it's better to use the 3 factorial so that it is smaller. But you can do it like this if you want. Okay, so now we want to add the other case, which I don't have a lot of room for. So here, notice we're going to use the same strategy. So I have 2 special students. So I want to know who those students are. So of my 4 students, I'm going to select 2. Now it's important that we select them at the same time because they're getting the same number of chocolates. So we select 2 special students. Now I'm going to give 2 chocolates to the first one that I select, to one of them. And then I'm going to give 2 chocolates to the next one, but I'm only going to have 4 left at that point. Okay, so this is give 2 chocolates each. Now, I'm done sort of in my picture, I'm done C and D. So I know C and D are getting 2, and I've given them the 2 that they get each. So I'm down to 2 people, okay, and 2 chocolates, and they're each getting 1. So whenever you have something like that, it's always just a factorial. So this is going to be times 2 factorial. So this is give remaining students 1 each. Okay, so then if you compute this, it's going to be 480 plus 1,080. So there's going to be 1,560 ways to give out the chocolates. Okay, now this technique is sort of hard to describe. I'm going to do the best I can here. So you want to give one group some objects from another group, okay, so that everyone gets at least one. Okay, now this can be done in different ways, so it doesn't have to be at least one, but like I said, this is hard to describe, this sort of category of examples. So what you want to do is determine cases, okay, if any. So it may be that you don't need them, okay, but sometimes you will. Okay, so determine cases, and then within each case, we're going to select special individuals. Okay, so these are from the first group, the group that are getting stuff. And what I mean by special is, maybe I should say, all that get a certain number of objects that you're giving out. Okay, so you want to select them, and then you want to give them their objects. Okay, and then you want to continue doing this until all objects are given. Okay, so that's sort of a description of what's going on here. Hopefully the example is helpful. Let's try another one. So suppose in a bin by the door, I have 12 pairs of shoes. So 24 shoes in total. And I reach into the bin without looking, and I grab 5 shoes. So first of all, I want to know in how many ways can I get exactly one matching pair. So again, for these ones, I like to draw a picture. 8, 9, 10, 11, 12. Okay, so these are my pairs. Okay, so it can be helpful to say, okay, what does this look like? So how would I get exactly one matching pair? Okay, well maybe I pick both of shoe type 3. Now I need 3 more shoes, and they have to be from different pairs. Okay, so I'm going to have something like this maybe. So I've picked a pair, and then I picked 3 singles that are all different. Okay, so here we're picking within groups of objects. Okay, and I want to know that I get a specific number from each of these groups. So what we're going to do is think about getting a shoe as a 2-step process. Okay, so each shoe has a type, okay, and then each of these has a left or right shoe. There are more colors. Okay, so each of these has a left and a right. That's why I've drawn them as 2s. Okay, so I want to know what type and then which shoe of that type. Okay, is what we're going with. So the number with exactly one pair, what I want to do, I'm going to do the pair first. Okay, so I'm going to select a type for the pair. Okay, there's 12 different types and I want to select one of them. So that's 12, choose one. And then, so multiply, we're going to select shoes of that type. Now I don't really need this here, but I want it to look similar to the next steps. So there's 2 shoes of type 3, and I want both of them. So I'm going to do 2, choose 2. Okay, now here it's important that we pick the single ones, the types, at the same time, because we're taking 1 shoe of each. Okay, so my next step, I want 3 types for the single shoes. So there's 11 types left because I already picked 1 type for the pair. So what I want to do is 11, choose 3. So that tells me that I've picked 5, 7, and 12. So those types. Now within each type, I want to select a shoe. So 1 shoe of each type. Could be the left, could be the right. So I'm going to have to do 2, choose 1 3 times. So I'm going to get 2, choose 1 cubed. Okay, so if you compute this, you should get 15,840 selections. Okay, that contain exactly 1 pair. Now what if I wanted at least 1 pair? Well, there's 2 different ways we can do this. So because we're only picking 5 shoes, the most number of pairs we can get is 2, right? Because we need 4 shoes then. So I could use my exactly 1 pair and then add the exactly 2 pairs case. Okay, or I could do the number in the universe and subtract the opposite, which is the number with no pairs. So using the complement rule. Both of these are the same. Okay, so this is 15,840. Now if I want 2 pairs, from my types, I'm going to get 2 pairs. So this is 2 types for pairs. Okay, and then I'm going to pick both of their shoes, so twice. So pick both shoes. So that's 4 shoes in total. So I need 1 more shoe, and there's 10 types left over. So I need 1 more type, and then 1 more shoe of that type. Okay, so this is 1 type for the single, and then which shoe I got. So using this way, it's going to be 15,840 plus 1,320, which is going to be 17,160. Okay, or if we use the complement, the universe is just pick 5 shoes from the 24 shoes, and then I'd want no pairs. So that means from my 12 types, I want 5 different types. And then from each of these types, I'm going to take 1 shoe. Okay, so using this way, we're going to have 42,504 minus 12, choose 5 times 2 to the power 5, which is 2,112. I think I made a mistake here. Yeah, sorry about that. Calculator mistake. So this is 25,344. So again, we get the same answer. Okay, so the technique here, so forgetting sort of the cases down below, the technique here is we want to select from a bunch of groups of things. Where you get a certain number from from multiple groups, or from each group maybe is better. So then what you want to do is for each, wow, I can't spell, for each different number, okay, so like I said, you get a certain number from each group. So for each different number, what you want to do is select select the number of groups with that number, so that you want to take. So in the example above here, we wanted one group that had 2 and then 3 groups that had 1. Okay, so you want the number of groups that where you're going to take that specific number, and then you want to select within each group, and you keep doing that until you get all the things you need. So for these, you want to think of a 2-step process. So you want to know which groups and then which items from those groups. Okay, so that's sort of the basic idea.